Here we'll have our video about how to find the nth term of any arithmetic sequence. So we're still chatting about arithmetic sequences. And when I talk about how to find the nth term, n is the value that we use to represent the sort of term spot in the sequence that we're talking about. So if I have a sequence, an arithmetic sequence that's -2, 4, 10, so on and so forth, I would say that this is my first term, my second term, my third term, and if I wanted to talk about, the 55th term or the 105th term, if I'm looking for the nth term, that's just kind of any value. How can I find any value in the sequence? So that's what I mean when how can we find the nth term? So if I take a look here, this says find the 8th term of an arithmetic sequence that begins with -2, 4, and 10. So to find the 8th term, this is the first, the second, the third. So I'd have the 4th, 5th, 6th, the 7th, and the 8th. So I could take a look here and see that my common difference is 6, and I could continue to add 6 each time, going up until I get to my 8th term. So 16 plus 6 will give me 22. 22 plus 6 will give me 28. 28 plus 6 will give me 34. And 34 plus 6 is going to give me 40. So that is certainly one way to do it. We would say that A of 8 is equal to 40. So this is notation meaning that the 8th term in the sequence, so the 8th term in the sequence is 40. That's what this notation means right here. So when we say A of 1 is equal to, this is saying, well, what's the first term? So A of 1 is -2. A of 2, I can see here, is 4, and so on and so forth. So number 2 here for our example problem says, try to create some kind of rule or formula to find the nth term and call this rule A of n. So let's take a look here. The first thing that I want to do is I want to organize the numbers in my sequence. So I'm going to go ahead and make a table. I will call it term number and actual term value. So here I have 1, which we really know is A of 1, A of 2 is the second term, the third term, the fourth term, and so on and so forth. I'm looking for A of n. So the first term that I have here is -2, 4, 10, and 16. And I know that my common difference here is 6. So there's 2 different ways to think about what's happening here. And the first way is to see that I am indeed adding 6 each time. And when I'm increasing or decreasing by a constant, I know that I can relate to a linear function. So we can go ahead and look at y equals mx plus b. So if I were to take a look here, my m would be my slope, which would be 6. And my b value, I can come and take a look, my y-intercept, if it were 0, my 0 term, or a sub 0, would be if I were to go the opposite way. And my term value would be -8. So I can come back to my purple color here, and I have -8. And so let's go ahead and write this, talking and using this a sub n. So I could say, to find any term number, I can take my common difference, which is 6, and multiply it by my term number that I'm looking for, and subtract 8. So we could say that a sub n is equal to my common difference times the term number plus the 0 term. So here is a rule that we can use to go ahead and create that. Another way that we could look at this is we could also say, well, I can take my first term, which is very common when we're talking about these arithmetic sequences. We're not often given the 0 term. We're just given term 1 of the sequence. So I can take my first term, so I can say a sub n is a1 plus my common difference times the term before it. So the term number before it. So instead of using the 0 term here, I can, and actually instead of 6, because 6 isn't always our common difference, I can go ahead and plug in d there. So we can really see that these two equations here are really the same. A sub n is a1 plus d times n minus d. And I know here that a1 minus d will give me my a0 term, which is what makes these two pieces equivalent. So this equation to find any number in an arithmetic sequence, students often really like because we don't need to find the 0 term and we can just plug in for things that we're looking for. And this one students also like because it reminds us of linear equations. So whichever equation you decide to use is totally up to you. They are both correct, and we just kind of saw going from here to here that these two are indeed the same thing. So we went ahead and created a rule. So number 2, created a rule for our nth term. Let's see if our rule works, and we will use this equation, or this version of the equation right here. So a of n is a1, which is -2, plus my common difference, which is 6 times n minus 1. And I'm looking to find the 8th term. So a of 8 is -2 plus 6 times 8 minus 1. And I'll continue up over here. So a sub 8 is -2 plus 6 times 7. A of 8 is -2 plus 42, which makes a of 8 40, which is exactly what we got when we just continued to add our common difference.